Imagine this, you're outside on a sunny afternoon helping a friend with some yard work. Suddenly you feel a sharp pain in your finger. Ouch, you've just pricked yourself with a rusty nail. It may seem like a minor injury, but beneath the surface, a microscopic battle is about to begin. Unbeknownst to you, the rusty nail carries with it an army of unwelcome invaders, bacteria. These tiny organisms are eager to make your body their new home, but luckily your body has a defense system of its own. The incredible immune system, this intricate network of cells and processes, works tirelessly to protect you from harmful invaders like the bacteria on that rusty nail. It's a complex system, but understanding its basic workings can give you a newfound appreciation for the remarkable way your body keeps you healthy. Think of your immune system as a highly trained army, with different types of soldiers, each specializing in a particular combat technique. There are scouts who identify the enemy, frontline soldiers who engage in direct combat, and even memory keepers who record past battles to prepare for future attacks. The moment that rusty nail breaks your skin, it triggers an alarm within your body. The first responders to this alarm are the macrophages, large white blood cells that patrol your tissues looking for trouble. Macrophages are like the heavy eaters of the immune system. They engulf and digest any foreign invaders they encounter, including bacteria, viruses, and even cellular debris. But macrophages don't just fight the enemy, they also alert the rest of the immune system to the threat. They release chemical signals like calling in reinforcements, which attract other immune cells to the site of the injury. Among these reinforcements are neutrophils, another type of white blood cell that specializes in destroying bacteria. Neutrophils are like the suicide bombers of the immune system. They release toxic substances that kill bacteria, but these substances also damage the neutrophils themselves. This self-sacrifice ensures that the bacteria are eliminated and the surrounding tissues are protected from excessive damage. These early responders, the macrophages and neutrophils, form the first line of defense of your immune system, also known as the innate immune response. This rapid and non-specific response is crucial for containing infections in their early stages, preventing them from spreading throughout the body. Imagine the innate immune response as the security guards of your body. They're always on patrol, ready to tackle any immediate threats, but they don't have the ability to remember specific enemies or mount targeted attacks. For that, your body relies on a more specialized branch of the immune system, the adaptive immune response. The adaptive immune response is slower to kick in, but it's much more sophisticated. It involves cells that can recognize and target specific pathogens, and it has the remarkable ability to remember past encounters, providing long-term immunity. Section 4. Calling in the reinforcements, the adaptive immune response. The key players in the adaptive immune response are lymphocytes, a type of white blood cell that comes in two main varieties, T cells and B cells. T cells are responsible for directly attacking infected cells, while B cells produce antibodies, proteins that can bind to and neutralize specific pathogens. But before the adaptive immune response can swing into action, it needs to be activated. This is where dendritic cells come in. These specialized cells act as messengers between the innate and adaptive immune systems. They capture fragments of pathogens, like pieces of a shredded enemy uniform, and present them to T cells, effectively showing the T cells what the enemy looks like. Once activated, T cells differentiate into different subtypes, each with a specific role to play. Helper T cells act as coordinators, releasing chemical signals that stimulate other immune cells, including B cells. Cytotoxic T cells, also known as killer T cells, are the assassins of the immune system. They directly target and destroy cells that have been infected by pathogens, preventing the pathogens from replicating and spreading. Section 5. Remembering the enemy, long-term immunity. Meanwhile, B cells, once activated by helper T cells, transform into antibody factories. Antibodies are like guided missiles designed to seek out and bind to specific pathogens, marking them for destruction by other immune cells or neutralizing their ability to infect cells. The beauty of the adaptive immune response is its ability to learn and remember. After an infection is cleared, some T and B cells become memory cells. These memory cells hang around in the body, carrying the memory of the specific pathogen they encountered. If the same pathogen tries to invade again, the memory cells can mount a much faster and more effective immune response, often preventing the person from getting sick. This is why you typically only get certain diseases, like chickenpox, once. So the next time you get a cut or a scrape, remember the incredible army of cells working tirelessly beneath your skin to protect you. The immune system is a marvel of biological engineering, and understanding its workings can help you appreciate the incredible power and resilience of your own body.